We are in 3.4, so let's look at the zeros of polynomial functions. So we are going to use a rational zero theorem to find possible rational zeros, and then we can test them out using the synthetic division, and then we'll find the zeros and then solve polynomial equations. Using the rational zero theorem is, let's look at this and see if we can use synthetic division on it. So when we have x plus 5, when we do synthetic division, we do the -5 inside the box. And then we'll list out our coefficients in decreasing exponent order. So go ahead and do that. I'm going to give you a second to do that. Okay, so whenever we get a 0 as our remainder, that means that -5 is one of our zeros. So we can rewrite this 4x cubed plus 19x squared minus 6x minus 5 to this being one of the factors. So I just rewrote our function, our polynomial, x plus 5 times what's left here. So this is our constant, this is our x, and this is our x squared. So it'd be parentheses 4x squared minus 1x minus 1. So using synthetic division to rewrite our polynomial in a factored form. Let's look at the rational zero theorem. So in a polynomial, we can find all possible zeros. So I'm going to write find all possible zeros. So the way that you find all your possible zeros is you use the fraction p over q. And so p is going to be all the factors of our constant listed out. And q is the factors of our leading coefficient. And then you just find all possible ratios. So you mix and match all the factors of our constant with factors of our leading coefficient. So you have lots of different ratios, and you can try those fractions out as zeros by using synthetic division. So we are going to list out all the possible rational zeros by looking at this first example. So it's P over Q. So remember, P is the are all the factors of the constant. So our constant is -3. So what are the factors?
1.
Plus and minus 1. and plus and minus 3. So if we really want to, we put 1, -1, 3, -3. And then Q is our leading coefficient, so it is 4. Our factors would be plus minus 1, plus minus 2, plus or minus 4. So we would list those out. 1, -1, 2, -2, 4, -4. So now we find every possible combination and then reduce that, if we can, as a fraction. So we're going to list out all P over Q. So I could put 1 over itself and 1 over -1, -1 over 1. All the mixtures of 1 and 1 just come out to be 1 and -1. And then our other constant would be 3 over 1, or -3 over 1. So that would be 3 and -3. Then I could list out 1 as our numerator and 2 as our denominator, or 1 over -2, or -1 over 2, -1 over -2, which all just comes out to 1/2 and -1/2. And then I could do 3 over 1 or 3 over -1. I've already done that, so that's already there. Now I could do 3 over 2, or 3 over -2, or -3 over 2, -3 over -2. So see all the possible combinations? So we do 3 over 2 and -3 over 2. We still have one other possible combination. That's 3 over 4, or 3 over -4, -3 over 4, -3 over -4, which would just be 3 over 4 and -3 over 4. So these are all the possible real zeros. So you could have imaginary zeros, but these are all the real rational zeros. And there's none of them that we need to simplify at all. Yes?
What about the 1 over 4?
The what?
The 1 over 4? You don't do positive 1 over 4 and then negative 1
Yep,
over 4?
we haven't done that one yet. Yep, good catch. So 1 over 4 and -1 over 4. Because we did 1 over 2, we just didn't use the 4. Good job. Okay, so let's do these next 2 examples. Find all the possible zeros from here. So our P value, P is -2, and Q is 1. So list out all the possible zeros of P over Q. So all the factors of 2 are plus minus 1 and plus minus 2. And all the factors of 1 are just plus minus 1. It's -1 times -1. So P over Q, our only options are plus or minus 1, plus or minus 2. So you'd have to try them all out. So we have a 1, -1, 2, and -2. You can write it either way.
How does it want us to do it, person?
I'd have to look at it. I'm not sure. If it allows for the plus minus, you can put that in. Let's look at the next one. What is P? Negative 26, and Q? Positive 4. So what are all the possible, or what are all the factors of negative 26?
2, -2, 13.
So 1, 2, 13, and 26. All the negatives, yeah. And then 4. 1, 2, and 4. Positive and negative. So P over Q. So we know it can be all of the P's, all of the factors of P, because you could always put those over 1. So those are always options. So plus minus 1, plus minus 2, plus minus 13, positive negative 26. And then you can do 1 over 2 and 1 over 4. So then we could do 1/2, 1/4, and then what else could we do? Then I do 2 over 1, which is the same thing as this. 2 over 2 is just 1. 2 over 4 is 1/2, so there's nothing new there. Now we can do 13, though. 13 over 2 and 13 over 4. And then 26 over 2 is 13. It's nothing new, so I wouldn't write that down. 26 over 4.
13.
Yeah, that's 13 over 2, so that's nothing new either. So there's no new ones with that. So those are all your possible zeros.
So a lot of Pearson questions.
Similar. Not too many, though.
27.
Okay, so let's look at example 4. So we're actually going to find all the possible zeros. So we have x cubed minus 3x squared minus 4x plus 12. So instead of just randomly shooting in the dark and saying, I'm going to try 5 as my factor, we can use this P over Q to find all the possible zeros and then start trying them out to see which one actually works. And then we can factor it all the way down. So we have P is 12, Q is 1. So really it's all possible, all of the factors of 12. So what are all the factors of 12? So plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. So those are all the possible ones that we can do. Okay, so you can start with any one of those and do synthetic division to see which one works. So I was doing this as notes earlier. And so, like, I did this, and I was like, oh my gosh, that doesn't work, that doesn't work, that doesn't work. So we're going to go through and try ones until they either work or they don't work. So I'm going to start with 1, just random. So let's start with 1. So then I'll put my coefficients, do my synthetic division. So go ahead and do synthetic division. I want y'all to try out different ones until you find one that works. I'm trying this one out. Let's see. So once you get a number that is not 0 at the end, that's your remainder. That means you did it That one is not. No, you did it right. It just means that it's not a 0. So I know 1 is not a 0. So then I could try -1. So I just did -1 and it didn't work either. 2 works? Okay.
You just took us in the calculator and see the zeros.
You can, but that's not.
Okay.
Yeah, you're not supposed to do that because we're learning it this way. So it's a different method.
We have to do it to all of them? Oh, that means we have
No, once you find one, then you can stop and I'll show you what to do next.
Yeah, because since it's extra than 30, I can 3.
If 3 doesn't work.
Okay, so 2 works. Once you find one, you don't have to keep on going because we can do something that's a little easier now. So what this tells us is that x cubed minus 3x squared minus 4x plus 12 is equal to x minus 2 times, we convert this to a polynomial. So this is the x, and this one is the x squared because you start off with constant, and then x squared. So this would be x squared minus x minus 6. So then can we factor this just using the sum and the product? What gives us a product of -6 and a sum of -1? So x minus 3, x plus 2.
Sure. Don't you figure?
So now, yeah, so now I can bring this down and we have x minus 2 right here. And then these guys go here. So what is our solution set?
2, -2, 3.
Yep.
It gets easier now, right?
Yeah. Sure.
Are we going to do example 4?
Yep. That's a different example, I guess. Yeah. So this is another example of finding all the zeros, just using a different one. All right, so let's look at this one. So we need to know all possible. What are all the possible ones? Possible zeros. So this is my P. This is Q. Just -2, the factors of -2 over the factors of 1. So what are all the possible zeros? Plus or minus 1 and plus or minus 2. Okay, we can start with any one of them. We just need to find one that works. So what do y'all want to start with?
+2.
+2. All right. So this would be 1, 1, -5, -2. Ah, that worked. So we can rewrite this. I'm not going to rewrite this anymore. I'm just going to write x, since it's +2, x minus 2 times Let's write this as a polynomial. X squared plus 3x plus 1. So now we need to factor this. I'm going to do it over here. Can we find a product of 1 that has a sum of 3? So we're going to have to use, it's non-factorable. So we're going to have to use quadratic formula. It's so easy whenever it's all factorable. But when it's not, you have to use that quadratic formula. So x equals negative b. So negative 3 plus or minus the square root of b squared, so 3 squared, minus 4ac, 4 times 1 times 1, all over 2a. So negative 3 plus or minus the square root of, let's see, so this would be 9 minus 4, yeah, 5 over 2. So that gets the other 2, and I can't simplify that anymore. So my solution set comes from over here. Don't forget about this one. It's 2, and then negative 3 plus square root of 5 over 2, and negative 3 minus square root of 5 over 2. Okay. Let's solve the next one, example 5. So we're going to follow the same procedure. So we're going to look at P, we're going to look at Q. So we need to know what all the possible zeros are. So it's P over Q. So we only have 13. 13's prime. So our only possible zeros are positive and negative 1 and positive and negative 13. What do y'all want to start with? Negative 1. Oh, that doesn't look good. So negative 1 doesn't work. So what should we try now? 13 doesn't work? You've already tried it? Huh?
Negative 13.
Does it work?
13 doesn't work.
1 doesn't work either.
1?
One doesn't look.
So it's gotta be
Negative 13.
I thought 1 worked. Let's try it. So that would be positive 1, so negative 5, 17, positive 17, negative 13, negative 13, 0. That does work.
That's awkward, Zach.
So that means that we have x minus 1 times, this is our constant, this is my x, this is x squared, and this is x cubed. So this would be x cubed minus 5x squared plus 17x minus 13. Okay. So this next one says possible rational roots. So the one that worked, what didn't work? -1 didn't work.
All of them going.
-13 didn't work. Okay, but 1 did. So this should be x minus 1. I don't know if anybody tried 13.
No, I didn't work.
Didn't work. Okay. So now we need to factor this next part. Since the rest of these didn't work, we can try 1 on this one.
No.
So if it didn't work originally, it's not going to work whenever you do your new polynomial. So we're going to try 1 again on this next part. So this was what was left over after we did synthetic division. So it worked. So that means now we have left x minus 1, and then this. This is our x, and this is our x squared, because you need that first number as your constant. So we'll rewrite this as x squared minus 4x plus 13. Yeah. So do we have a product, factors that give us a product of 13 and add to give us -4? No. So it's non-factorable. So we got to use our quadratic formula. So x equals -b, so that'd be a +4, plus or minus square root of b squared, so -4 squared, minus 4 times 1 times 13 over 2 times a. So that's 16 minus, what is this? 4 times 13. It's like a deck of cards. 52. 36 minus 52. -36 over 2. Can we simplify that? Yeah, 6i. So 4 plus or minus 6i over 2. Can we simplify it even more? You can simplify both sides. Like the 4 over 2 is 2. And the 6i over 2 is 3i.
Instead of doing a test, let's just count the graph and test.
So our solutions are, I can't fit them in there. 1, 1, and then 2 plus 3i and 2 minus 3i. I'm just going to write it like this.
It's right.
Let's do one.
No, they're both 1. So that means
So wait, why can't you just write it just once?
probably could. Yeah. Remember that multiplicity thing? So if it has a double multiplicity of 2, what does that mean? Because in our factors, it's like this. It's going to change direction there. So it's going to hit it and change direction. All right, let's look at our last example. An incomplete graph of the polynomial function is shown. Find all the zeros of the function. Without using a graphing utility, draw a complete graph of the function. Okay, so what clues can I use on here to find what one of the zeros is? It's right here, but what number is that?
-3.
Yeah, you got to look here. Yep. And so it's saying this is -5 to 0 going by ones, right? So this would be -1, -2, -3, -4. So one of our zeros is -3. So we're going to use that and use synthetic division to find another 0. We're going to keep on factoring it down until we find all the zeros. So we're going to use this because they gave that to us. So we have -1, 2, 11, and -12. So use synthetic division. And it's so easy to mess up on this. You just got to be real careful with those positives and negatives. We knew it was a 0. This just proved that it is right. So now what we have left is x plus 3 times, this is our constant, this is our x, this is our x squared, negative x squared plus 5x minus 4. So I need to factor this. I would need to factor out a -1 first because I don't want that leading coefficient to be negative. So I'm going to put -1 out front, and then x plus 3 times, that'll be x squared minus 5x plus 4. Now we need to see if it's factorable. So the factors of 4 that add to get -5. -1 and -4, because -1 times -4 is +4, and then you add them, you get -5. So let's rewrite this. And then let's write our zeros. It'll be -3, +4, and +1. And if that is the case, how does this go on? So it'd be, this is -3. Let's do 1, 2, 3, 4. So we know there's a 0 at +4 and at +1. So it's going to kind of go like that, maybe. We don't know how high up this goes, but we do know that those are 2 zeros. All right, that is the end of the notes.